What's up guys, welcome to day 20 of May 2020 LeetCode daily challenge. Today's question is kthSmallest element in a BST. So the problem statement is, given a binary search tree, write a function kthSmallest to find the kthSmallest element in it. So kthSmallest element, you may assume k is valid, 1 is less than k is less than or equal to BST total elements. All right, and let's look at an example. So let's talk about what a kthSmallest element is first. So kthSmallest would be so given a binary tree, if k is equal to 1, it would mean the first smallest element. If it's 2, then second. If it's 3, the third smallest element, and so on and so forth. So given for example this tree and k equal to 1, the kthSmallest element I can see directly is 1. So let me talk about how we're going to basically go through this. We will use the property of binary search tree, and the property of binary search tree is that the left of a given node is always less than the node's value, and the child to the right of the given node is always greater than, its value is always greater than the given node. So you can see here the value 1 is less than 3, and so it's to the left, and the value 4 is greater than 3, so it's to the right. And similarly, if you look here, the value 2 is greater than 1, and so it's to the right, and towards the left we don't have any other values. So our solution basically would consider an in-order traversal. So once you are traversing a binary search tree in order, it will always go through all the elements in a sorted fashion. So for example, we were to do an in-order traversal on this tree. So the first element that we would be traversing here would be 1, and the second element that we would be traversing, it would be 2, the next element would be 3, and the following element would be 4. But since we're given k equal to 1, we could essentially just stop at the first value that is encountered, which is 1, the very first element, which is 1, and we can return that value. If we were given k equal to 2, we would first look at 1, then we would look at 2. 2 is the second value, second greatest value, and we can return that. And similarly for 3, and similarly for 4. So let's look at a case where k equal to 3 in this given tree. So k equal to, in order to find k equal to 3, that is the kth element would be 3. How would we go about traversing an in-order traversal of this binary search tree would be, we start the traversal at the root. First we're going to check an in-order traversal. Basically what it means is, we first look to the left of the tree, then we look at the value of the tree, and then we look at the right child of the tree. So and if there are any other values to the children, we look at those first, and then we process the child itself. So let's see how it's going to work. So in order traversal first looks at the goes here. I mean, the first element we're going to give is root, which is 3. We will look at the left value first. So the left value here is 1. Now we will look for the left child of 1 if there is any. The left child is null, so we will pass on to this value here, which is 1, and basically 1 is the first kthSmallest element. Then we will look at the right subchild of this tree. When we move to the right child, we'll again first look for if there is any left value. If there is none, then we process the node's value itself, and then we look at the right child, and there is no right child, so 2 is the second kthSmallest element. Since we've processed this node also, we will now fall back here. We've already processed this node, we will fall back here, And so we've basically, in a sense, what we've done is we've processed the left subtree of 3. So basically you first process the left subtree, then you process the node's value, then you process the right subtree. So now once we've reached here k, as if you can recall, we set k as 3. So we've found the value and we can basically return this. So now let's look at how we would end up coding this. Let's put it in code. So let's declare two variables, int count, which will hold which element we've reached. Then we will hold the answer value. Since we're going to be doing this recursively, we would need an external variable which is holding it. So let's hold it in answer. So now what we're going to do is we would first, as I said, look at the left subtree. So how do we do the left subtree is we first check for if it's not null. So if root.left not equal to null, then we do kthSmallest, that's kthSmallest root.left comma k. So what this would do is this would start processing the left subtree. Now once we're processed with the left subtree, the first thing that we would do is we will check if ++ count. So we're pre-incrementing the count before we get into the if statement, is equal to k. If that is the case, we say answer is equal to node.val, and this is the value that we're interested in. So but since we're incrementing these values, we would also add another condition here which would say that if count is less than k, because if the value of count is equal to k, this is what we are interested in, and if not, and we don't want to process the tree any further, we just want to return the value. So for processing the right subtree now in the in order fashion, we are going to do a right not equal to null, and similarly count is less than k. Only then we move to the kthSmallest element here. So kthSmallest, let's see, root.right comma k. Having done this, now all that we're left with doing is return answer. So let's walk through this code again. So root.left and count is less than k. Root.left is not null and count is less than k. Then we process the left subtree of the given node. Once we've processed the left subtree and we've visited all the nodes in such a fashion, we are going to check for these values. So every time we're visiting a node, we are incrementing the value of count because we've visited, say, k equal to 1 first, then k equal to 2, not k equal to 2, count equal to 1. So that's the first element that we visited. Then we're visiting the second element, then we're visiting the third element. So whatever the value of k is, we're checking against this count. If we've encountered that value, we don't want to process any of the nodes, and we would want to pop back in recursive manner and return the value of the answer that we found. So this is root and not node. So let's quickly run this code and see if we're getting the correct answers. Root.right not equal to, and any other errors, and count. Yeah, so let's run it. So getting answer equal to 3 for this particular subtree. So let's do a custom input and let's try taking this here. We can visualize this tree here. We're giving k equal to 1 and run. So it does give us the expected value. If we were to put in 3, for example, this is what it returns. Now let's change up these values a little. Let's make this 4 so that they're not in a numerical order, and let's make this 5. So what we can see is 1 is less than 4, obviously 2 is also less than 4, it's greater than 1, and 5 is greater than 4, so it's the right sort of BST that we would want to process. And with 3 our value should now be 4, so let's see if it returns the correct value. Awesome, and it does. So I think we're in a position to submit this. Let's submit it and see if it's accepted. Great, so it's been accepted and we've passed 91 out of 91 cases. The runtime is 0 and we're in the 100th percentile. Great. So that's kthSmallest element, and that's day 20 of May 2020 LeetCode challenge. Thank you guys for watching. If you liked the video, hit the like button. It really helps the channel grow. Do subscribe to the video if to the channel if you've already not subscribed. You can see a subscribe button on the right corner, and hit the bell icon. I am trying to produce at least one video per day. There could be more.